All right, today we're going to do something really interesting. We're going to build a bridge between the incredibly strange discoveries of modern physics and some of the deepest questions we can possibly ask. We're stepping beyond matter to try and sketch out a whole new map of reality.
And really, that's the central question we're tackling here. I mean, if solid stuff isn't actually real, then what is? We're about to go on a journey, starting with that big shift in physics that basically erased solid matter, moving to the profound questions this raises, and then finally exploring a proposed answer for what holds it all together. Okay, let's dive right in. To really get what's being argued here, you first have to appreciate just how radically our scientific picture of the physical world has been flipped on its head over the last 100 years or so. You know, for the longest time, the classical view was simple. Reality was made of tiny, solid bits, kind of like microscopic billiard balls. But that whole picture just dissolved. It started with theories of electromagnetism, and it all culminated in what we now call quantum field theory, or QFT. And what QFT tells us is that the fundamental reality isn't the particle, it's the invisible field. Think of a field like the surface of a pond. A particle, say an electron, is just a ripple, a stable little disturbance on that pond. And this isn't some abstract theory either. The device you're watching this on right now works because transistors are manipulating the quantum electron field. Lasers, LEDs, all of that is tech built on our understanding of these fields. Now, what's so wild about this is just how total the shift is. I mean, think about it. We've gone from a universe made of things to a universe made of pure pattern. Mass isn't even something a particle has. It's just a measure of the energy that's bound up in its stable pattern, exactly like Einstein's A equals mc squared would suggest. So any object, you, me, this screen, it's less like a brick and more like a whirlpool in a river, a stable, dynamic form that manages to hold itself together over time. So here's the crucial point. The search for the ultimate building block of reality didn't lead us to some smaller, harder bit of stuff. It led us to pure pattern, to structured dynamics. It seems that at the very bottom of it all, reality is a system of relationships, not a big collection of lonely, isolated things. So, okay, this new picture from quantum field theory, it's unbelievably powerful, it's predictive, it works, but, and this is a big but, it leaves these huge, almost philosophical questions just hanging there, completely unanswered. This is the first major question, and honestly, it's a stunner when you think about it. If the entire universe is just this sea of churning energy fields, why does any stable structure exist? Why does an electron or an atom or you persist? What stops everything from just dissolving back into a chaotic soup of energy? What's holding that whirlpool together? And then there's the second mystery, which frankly might be even deeper. Why do these energy patterns follow these consistent, beautiful mathematical laws? Why isn't the universe just random, chaotic noise? And maybe the craziest part of it all? Why do our brains, which are a product of this very same universe, have the rational toolkit to actually understand those laws? And this is where you really hit the limits of the scientific method itself. Physics is an incredibly powerful tool for describing how the universe behaves. But to even get started, it has to assume these foundational principles. It takes for granted that reality makes sense, that laws are consistent, and that structures are stable. But it can't explain why any of that is true from within its own framework. So how do we even begin to approach these questions that physics itself brings up but can't solve? Well, the source material we're digging into today proposes an interpretive framework, a metaphysical one, that's built on 3 core principles. Okay, first up is light. And right away, let's be super clear. We are not talking about photons from your light bulb here. We're talking about ontology, the study of being, of what it means to exist. Ontologically, light is the principle of intelligibility itself. It's this idea that reality has a rational, knowable structure, the very thing that makes science possible in the first place. All right, next we have life. And just like with light, you gotta think bigger here. We're not just talking about biology. Ontologically, life is the principle of dynamic, self-maintaining existence. So if light is the rational blueprint for a stable pattern, life is the principle that actually makes that blueprint real and helps it stick around. It's the reason a particle can hold itself together as a coherent thing through time. It is the principle of being. And the third piece of this puzzle is love. Now, as an ontological term, you have to get the whole greeting card idea out of your head. This isn't about emotion. Think of it more like a unifying, ordering attraction. Love is the principle that pulls distinct parts together to form a bigger, stable whole, but without erasing what made them individual in the first place. It's why electrons and nuclei form a coherent atom. It's the principle of relational unity. Okay, so on one hand, we have these discoveries from modern physics, and on the other, we have these three deep ontological principles. So how in the world do they connect? Well, this is where it gets really fascinating. The framework we're looking at proposes a stunningly direct alignment.
So look at this table. Seriously, this is the conceptual heart of the whole idea. It maps the language of physics directly onto this metaphysical framework we've just built. The fundamental intelligible fields, they correspond to light. The stable excitations of those fields, the actual particles, they correspond to life. And the interactions and forces that create stable systems, well, those correspond to love.
So what this framework is really getting at is that the physical laws we discover aren't just some random rules. They're mathematical expressions of these deeper truths. The stability of the universe isn't some cosmic accident. It exists because reality is grounded in a rational blueprint that we're calling light, an actualizing principle we're calling life, and a unifying coherence that we're calling love. Now look, whether you fully buy into this mapping or not, just thinking about it has some really profound implications. It starts to change how we view science itself and what it even means to be doing scientific inquiry. Okay, so for one thing, this view is a direct challenge to what we call material reductionism. If intelligibility, the very structure that science needs to even work, is a fundamental feature of reality, then you can't fully explain that structure by just reducing it down to a bunch of mindless random parts. The rational map, in this view, isn't just in our heads, it's baked into the territory itself. And this offers a potential answer to what's famously been called the unreasonable effectiveness of mathematics. Why on earth does math work so well to describe the universe? This framework would suggest it's no coincidence at all. Our ability to understand reality isn't just some lucky evolutionary quirk. It's possible because human cognition, which is fundamentally rational, reflects the deep, intelligible structure of the cosmos. Our minds are, in a very real sense, tuned to the frequency of reality. So, to bring it all home, this framework suggests that the deepest findings of physics, instead of pointing us toward a cold, meaningless universe, actually point in the complete opposite direction. They reveal a reality that is fundamentally intelligible, dynamically alive, and coherently unified. And so all of this leaves us with one final and I think really provocative question to ponder. Is physics just a description of brute facts? Or do its incredible discoveries about the elegant, lawful, and relational nature of our universe implicitly point towards something deeper, a more meaningful reality? Definitely something to think about.